value. So parent function absolute value is absolute value of x. Okay, so this is my parent function. So here we're going to answer some questions about the parent function. So if you need to refer back to the graph, you can turn your page back. It's when you have the full arrows on both sides. Okay, so if you have, I'll kind of draw a rough sketch here as well. Okay, so that's our parent function. So the domain of that is, what are the x values of that function? Well, the x values stretch all the way across the x-axis, so from negative infinity to positive infinity. And then the range is the lowest y to the highest y. So the lowest y in an absolute value is going to be equal to 0 when you have that parent function. And it should make sense because you should have no negative outputs when you're talking about absolute values until you start including some transformations. And it goes all the way forever in the positive infinity direction. Okay, so that minimum point, the lowest point of our parent function is 0, 0. It is continuous because even though it turns, it will go on forever. And then for when x is less than 0, that's our left-hand side. Okay, our left-hand side is when the rate of change is a -1. And then that right-hand side, for when x is greater than 0, our rate of change is a +1. Oops, I want to change that color so you can see what I'm talking about. +1. So for when x is less than 0, we're talking about the left-hand side, so we have a negative slope. And we're talking when x is greater than 0, we're talking about the right-hand side, which means we have a positive slope. So those are two things about the parent function. So now we're going to look back at Michel's piecewise function. So just to remind you, going back to page 1, I'm talking about Michel's piecewise function, which is, I'm going to use in part B, so this part right here. So I'm going to take that and turn that into the absolute value to match this graph. Okay, so in both cases we have the point 3, 0, so x minus 3, that's going to exist in our absolute value. And then this slope, so this slope of -2 or +2, which one do I use? Well, to turn this into the absolute value form, okay, Michel is equal to, I know I'm going to have an absolute value, and I'm going to have this x minus 3 inside that absolute value. And with that slope, if you use the positive, you can put it on the outside. You can also put it inside, so it can be 2 times x minus 3 if you use those parentheses. Okay, you could also use the negative because it's always going to get your values out to be positive. If the negative is inside, you can still do that. What you cannot do is put the negative outside the absolute value. So any of those options are great. Okay, so your a value can be on the outside, or that slope can be on the inside. But either way, make sure that it is a positive if you do it on the outside. So that is what we have. If you wanted to stick to context, you could add a restriction from 0 to 6. If we're still talking about Michel in context, okay, for that actual graph. If we took that away, if we took the context away, okay, how would the original piecewise function change if the context was taken away? How would that change? So I'm going to use a different color. Basically, I'm going to pretend distance doesn't exist anymore, time doesn't exist anymore. How does that change? That changes just by making the entire graph continuous. So if I put arrows on the end, that changes. So do the equations change? No. But what changes are my restrictions. So my equations are still -2 times x minus 3, +2 times x minus 3. But now those restrictions change. So -2, the left-hand side, exists if x is less than 3. The right-hand side, the 2 times x minus 3, exists if x is greater than 3. Again, the turning point needs to be included, so this time I'm going to do the top one. So context versus not context. Continuous versus continuous on a small domain. Okay, so to summarize everything we just talked about. Okay, the absolute value function. Absolute value function has a parent function of absolute value of x. So f of x equals absolute value of x. Okay, this can be written as a piecewise because absolute value of x is going to go up and to the right and is going to go up and to the left in both directions in the same rate. So, piecewise version, the left-hand side has a negative slope, the right-hand side has a positive slope. The left-hand side exists when x is less than 0. The right-hand side exists when x is greater than 0. Again, the 0, 0, the minimum exists in one of them, so I'm going to choose the second one. Okay, and then every time your domain should be negative infinity to positive infinity, and your range should be 0 included to infinity. Okay, so I'm going to have you try these last few questions on the back page. Okay, so pause this video and try those questions. Okay, I am going to walk through these just in case you were confused. If you just want to see the answers, you can go ahead and fast forward. So on this, I wanted to see what would happen if I changed the graph to absolute value. So if we remember, negative outputs change to positive. So negatives turn positive. So I'm going to zoom in on this graph. Negatives turn positive. So what I mean by that is, for instance, if I choose a point that has a negative output, this point right here has an output of -2. If that -2, what's the absolute value of -2? 2. So that actually turns to +2. Next point, right here, -4. Absolute value of -4 is 4. So these are all turning positive. So each one of these points is turning positive, and it's keeping the same rate as the other side, just making it positive. So what's truly happening here is that this entire piece down below is getting reflected up at the x-axis because these negative values are turning positive. So the original function that was written there was -2 times x minus 3. And then if I actually write this as an absolute value function, now that I turned it into absolute value, again, I could make it a +2 on the outside and x minus 3 on the inside, or I could put the 2 on the inside, but making sure to use parentheses. If I pretend there's arrows on the end, this is a continuous function. It should have arrows on the end for future. Okay, and then creating that into piecewise is actually what we did up above for Michelle's graph. So this is actually the same exact graph as Michelle, just taking away the context. Okay, last question. This is kind of just to introduce what's going to be happening next time. So if you're confused and you're overwhelmed, you don't have to worry about this question. But if you want to see what this is going to look like and what's going to happen to this, if you just use a table of values to help you estimate what's going to happen, you know what? I'm just going to actually say, don't worry about this. So if you didn't get to this, don't worry about it. We're going to talk about it next time. All right, hopefully you did okay with these. There's no homework, so that way we can kind of wrap this up together when I see you next week. Have a great long weekend. Bye.